Okay, so we are solving quadratic equations still. We did graphing, table, and factoring. So in each of those, we looked at it as ax squared plus bx plus c equals 0. All those equations we were just solving were in that form. So what we're looking at today is two different parts of that then. All right. The one you were looking at here while we're solving with just using square roots is that in these situations that you were looking at yesterday for the assignment is the fact that in that situation we have ax squared plus c equals 0. There's no b term, okay? Or b would be 0. So for solving these this way, we've got that b is equal to 0, so we're always just going to have ax squared plus c equals 0. So we could have two solutions. We have a positive or a negative. So if we're taking the square root of a number, all right, when we're solving an equation, we're going to get two solutions. And so we'll look at them as we go here. Right? So in general, this is the square root property. To solve a quadratic equation in the form of x squared equals a, we're going to take the square root of both sides. And so for quite a few of you, the work I didn't see, this is the work that I want to see. All right, so we're going to go through a few of them. And if you look at the example up here, all right, that x squared equals 15, you notice that they left it as the square root of 15. And so in some situations, they're going to ask you to find the decimal, to round to a certain number of decimal places, and we'll do that. But if they don't, then we will do exact values like they show here. Then we'll just leave it as the square root of 15. Right? So if x squared equals a is a positive real number, then x equals plus or minus the square root of a. So x squared equals 69. So I want to actually see from you, taking the square root of both sides. And when we're solving equations, and we take the square root of both sides, we get two answers if a is positive. And as we just saw when we tried to graph those with this one like letter B, and the fact is we can't take the square root of a negative number. Right? So in those situations there is no real solution. So when a is positive, we get two real solutions. When a is negative, we get none. So this is a situation where it's already set up. X squared equals a. So what if it's not set up that way? So what if it's set up so that we have ax squared plus c equals 0. So if it's set up like ax squared plus c equals 0, then the first thing we want to do is isolate the squared term. All right, so that means we want to get x squared by itself. So if it's not written in this form, then we want to get it in that form. And this is only when there's no b term, all right, which means there's no x. So I don't have plus 5x or minus 3x. This is only when it's just x squared and constants. So when we isolate it, which you've done a lot of this in the past, it means we just want to get it by itself. So we'll subtract 7 from both sides. So we get x squared equals 0. So take the square root of both sides. And this is the one and only case where there is only one solution. Because since 0 is neither positive or negative, and the square root of 0 is 0, you just get 0. So when you have an A and a C, the first thing we want to do is move the C, and then we're going to divide by A. But we're going to leave this, if it is a perfect square, all right? So if the numbers are 1, 4, 9, 16, 25, 36, if they're perfect squares, we're not going to divide, we're just going to write it as a fraction. Okay? So our first step, add 49 to both sides. We want to get the x squared term by itself. All right, since I want to get it by itself, I want to get rid of that 16 because I want it to just say x squared equals. Since 16 is a square, we're just going to write it as a fraction then. We're not going to actually do the division. So divide by 16. So we get x squared equals 49 over 16. We're not going to take our calculator and find a decimal number. All right, we're going to leave it just like that whenever those two numbers are squares. So that's why it's important that you're familiar with them. Okay, well, you now have them on that sheet, so you have them up to 10 anyways. Then take the square root of both sides. So my answer then is going to be a fraction. Square root of 49 is 7. Square root of 16 is 4. So you get plus or minus 7/4. So whenever the numbers are perfect squares, you should always have an exact value. Always an exact value. So here we have x squared equals 15 again. All right. Showed this in that example, but we're going to bring it back, and we want to find the answer and approximate it to the nearest hundredths. How many decimal places is hundredths? Okay, so 2 decimal places. Right? So we'll take it says the exact value and rounded value. So we take the square root of both sides, and we get x equals plus or minus. Since there is not a square root of 15, we'll write plus or minus the square root of 15. Okay, then we're going to find the approximate value. So take your calculator then and do the square root of 15 with your calculator. And you're rounding to the nearest hundredth, so 2 decimal places. So we are going to say approximately then. All right? It's not equals now, it's an approximate. So that's a little squiggly equal sign. And plus or minus and 3.87. So when they ask you to find the approximate, 2 decimal places, still going to have plus or minus. Okay, let's look at a word problem then with him. All right, so Ms. Perzada building a retaining wall along one of the long sides of her rectangular garden. The garden is twice as long as it is wide. It also has an area of 578 square feet. What would be the length of the retaining wall? All right, so what's the first thing we need to do? What should I do first? Okay, we need to find out how wide it is. So what should I do on my paper? Should I do anything on my paper except for just writing stuff down? Okay. Draw a picture. Always a good idea. So first thing I'm going to do is I'm going to make a rectangle and label the sides of that rectangle. So I always think of rectangles as length times width, or length and width. And reminder that the area is equal to length times width. Right. So what do we know about the length, the comparison of the two? Josh? Okay, so L is equal to 2W. So we'll plug in what we know. We know the area is 578. We know the length is 2W and the width is W. So we're going to use that information to find out the length of the retaining wall. So 578 equals 2 times W squared. All right, so here we have that situation. So we need to solve for W so that we can find L. All right, so you go ahead and do that. All right, so when you solve this, you get W squared equals 289, right? Because you got to divide by 2. And we take the square root of both sides. So we get that W equals, wait a minute, that's plus or minus 17, right? Right? And we're talking about the width of a wall or width of a rectangle. Can that be negative? No. Okay. So there's only one. So it can only be a positive 17 because the length has to be a positive number. Now we're trying to find the length of the wall. We know the width is 17, so the length is going to be 34 feet, 2 times 17. All right. So you would then write me a sentence that says the length of the retaining wall would be 34 feet. But just remember, if we're dealing with time, dealing with the length of something or a distance, those can never be negative. So make sure if you end up with a negative number that you ignore it and only take the positive numbers then. All right. Okay, so after filling out this table and really paying attention to this, the fact that if I have a plus b squared, it equals a squared plus 2ab plus b squared. And if you look over here on the board, on the whiteboard, I actually have that written on here because this is something that in Algebra B, Algebra C, and those of you who are going to go on and take pre-calculus, if you can remember this, it makes things a lot easier for you. And I had to remind the pre-calc students because they use it almost daily. And so having that in your mind that you can do that will make things easier for you. Okay? So the trinomials in the table are perfect square trinomials. In each of them, how is the constant term related to the coefficient of the x term? All right? And so here's what it is. It's half the coefficient squared. All right? The constant term is half the coefficient of the x term squared. And we're going to write it more officially here in just a minute. Okay? So for number 3, Ben, what goes in that blank space there? 36. Okay, good. 36. Okay. So if I write it as a binomial squared, that means if I take x squared minus 12x plus 36, and I write it as a binomial squared because this is what we're going to be doing with completing the square. All right. What goes in the parentheses then? Jackie, can you tell me? It's okay. Louder. Not in here, no. Good try though. All right, so let's go back up here for a second. Look at these. All right, x squared minus 10x plus 25 was x minus 5. X squared plus 6x plus 9 was x plus 3. X squared minus 8x plus 16 was x minus 4. Did you get the 36 here? Okay. All right, and what did you do to get 36? What's half of 12? Okay, all right. So you got it. You just said half of 12 squared is 36, right? Okay, so that's what goes here. Half of 12. X minus 6. Because if I FOIL this, x minus 6, if I multiply it out, I'm going to get x squared minus 12x plus 36. So we're working with perfect square trinomials, which means that this trinomial I have, when I factor it, I can write it as something times itself, which we'll write as squared. And the reason that is so that we can solve it. All right? We'll be able to take the square root of both sides. Okay, so let's look at those a little bit further. All right. So, completing the square, here's the formal definition. To complete the square of x squared plus bx, all right, which is what we just looked at, the x squared minus 12x. We're going to add half of b squared to it. All right, so which is what we just did right here. Half of b was negative 12, half of b is negative 6, and when I squared that, I got 36. Okay. Half of negative 12 is 6. Square that, we get 36. All right, for completing the square. So we're going to get half of b squared, add it to the expression, then that gives us a perfect square trinomial, which then we can write it as a binomial squared, which is what our goal is, to get to that point. All right, so here they have x squared plus 6x plus 9. We know that because we just did that one. But half of 6 squared is my 9, And so when I write it as a binomial squared, it's going to be x plus 3. So here's the, using algebra, the definition of it. Right. So we've got x squared plus bx. We're going to add b over 2 to that, b over 2 squared to that. And then when I write it in factored form, it's going to be x plus b over 2 squared, writing it as a binomial squared. All right. So here we have two of them we're going to do. We're going to complete the square, and then we're going to write it as a binomial squared. All right, so we got to find out what goes in that blank at the end. And then we're going to write it as a binomial squared. Now, when I do this myself, when I'm doing them, completing the square, I have a specific pattern that I work with, okay? And I think it works for some people. Other people would probably just as soon, would rather just focus on how this is done, okay? And that's fine. It just depends on you. So here's what I do. First thing, I'm bringing the x down, put it in the parentheses. This is before I even do this part, okay? So I think of it, okay, what's half of this number? So I'm going to put half of that number down here. And half of 2 is, all right, so we got plus 1 there, okay? And then I'm going to go up here and I'm going to square it. And 1 squared is 1. So we have x squared plus 2x plus 1. When I write it as a binomial squared, I get x plus 1, that quantity squared. Okay? So I like to go to the binomial squared before I actually complete the square. Now, do you have to do it that way? Absolutely not. It's all a matter of preference for you. Right? If you'd rather complete the square and then do it, and then write the binomial squared, that's fine. All right. So in letter B, it says x squared minus 6x plus some number. So I put my x here. All right. Then I'm going to bring down half of that number. And half of 6 is 3. So this is a negative 3 because that's a negative 6. All right, and then I go up here and I square it, and 3 times 3 is 9. All right, so here's one for you then. Let's see, one that we didn't do. Yeah, let's do this. All right, so complete the square. All right, and write it as a binomial squared. Complete the square and write it as a binomial squared. There's the basics of completing the square. So now what we're going to do is we're going to actually solve equations by completing the square. We did solving quadratic equations by graphing. Find out where the graphs cross the x-axis. In a table, find out where the equals 0. And we did it by factoring. Now we're going to do it by using the completing the square. And then on Monday, we're going to do what's called the quadratic formula, the last method for doing it. Right? So when we were doing factoring and graphing, we said, okay, we've got to have x squared plus bx plus c equals 0. When we were doing it with graphing and factoring. But when we are completing the square, it's going to look like this. The variable terms are going to be on the left side of the equal sign. The constant is going to go on the right-hand side because we're going to complete the square on the left-hand side to solve the equation. Right? So we write the equation in the form x squared plus bx equals c. So we're going to find b over 2 squared so that we can complete the square. And when we do that, we have to add it to both sides of the equation. Factor it, which we're going to do it all at once, do those things at once. Take the square root of both sides, what we were just doing in the other problems, right? And then we'll find our answers. Right? So this is in your book, so you can look it up later if you need to. All right? So let's start with letter A. And we'll see how far we get to B. Okay? It says x squared plus 16x equals negative 15. Now, when you write it on your paper, okay, they've started it for us just the way we want it. The variables on one side, constant on the other. When you write it on your paper, leave a space between the x and the equal sign, because you need room to be able to complete the square. Right. So once you write it in this form, then, once you got it that way, put your parentheses for your binomial squared right below it. Right. And then we're going to do what we just did. Okay? We're going to complete the square on the left-hand side. So Aaliyah, what goes in the parentheses? Okay, so we put x plus 8 here. Okay, inside the parentheses, because half of 16 is 8. Now, we need to square that 8, and we're going to add 64 then to the left-hand side. But you have to remember the rules of solving equations. If I do something to one side, I also have to do it to the other. So if I add 64 to the left-hand side, I have to add 64 to the right-hand side too. Okay. So then we have negative 15 plus 64 is 49. Now we basically have what we did with those other problems when we were just taking the square root. Because now on the left-hand side, I have something squared. The right-hand side, I have a constant. So I'm going to now take the square root of both sides. When I take the square root, the square is gone, so I still have x plus 8. And since I'm solving the equation, get plus or minus 7. Okay. And then we subtract 8 from both sides. So now we get two answers, okay? Because this is plus 7 and minus 7, or a positive 7 and a negative 7, and we're subtracting 8. So 7 minus 8 is negative 1, and negative 7 minus 8 is negative 15. All right, so you have to do both 7 minus 8 and negative 7 minus 8. So this is our answer. Negative 1 and negative 15. And so if we added the 15 back over and graphed that, we would find it crosses the x-axis at those two spots. Okay. All right, so have enough time, just watch, okay? All right, everybody just watch this one, because I might go faster than what you can write. Not on purpose, but we're running out of time. All right, so letter B. Just the variables are on the left side. So the first thing I've got to do is add 6. And you notice I left a space before my equal sign. Now I can complete the square. So x minus half of 4 is 2 squared. And then I have to add 4 to both sides. All right, so half of 4 is 2, and 2 squared is 4. You got to do it to both sides. So I get 10 over here. So once again, we got it. So we have something squared. A binomial squared equals a constant. So we take the square root of both sides. So we get x minus 2 equals plus or minus the square root of 10. Right? Now, in these problems, if you have a radical that you cannot simplify, okay, it's not a perfect square, you're just going to leave it as it is. Okay? So we add 2 to both sides. So we get x equals 2 plus or minus the square root of 10. We're always going to write this number before the plus or minus. Okay? So if you get a number that's not a perfect square, just leave it as it is. Later on, we'll learn how to simplify those if it's possible they can be simplified. Okay? So you've got your assignment. All right, there's only a few of them. Tomorrow, our focus is going to be almost completely on completing the square, so you get lots of practice with it.